Cool. So reesterification is effectively when you are now making a fatty acid, lengthening it again, along with then you can eventually attach it to another glycerol. So it turns out that's how we're going to be able to restore or just store fat in the first place in the body. So we naturally want to be, well, people don't want to be able to do it as much as they end up doing it with the amount of body fat they have, but we want to be able to do this as a means so that we're going to be able to store fat. And difference between long chain, medium chain, and short chain fatty acids, it's literally the length of the fatty acid. That's it. Long chains, if I remember correctly, are about at least 12. Medium chains are usually between 6 to 10, and then short chains are really short. We're talking about 4 carbons. And effectively, they're all going to be oxidized the same way. The key is we oxidize them 2 carbons at a time. So obviously long chains we get more energy from because there's more of those carbon bonds that we can break. And the other thing that's fascinating is medium and short chain fatty acids don't use specific transporters to get in the cell. They can actually go through the phospholipid bilayer. So it actually makes things a lot easier to go ahead and get that into the body. But it doesn't really seem to give you a major advantage for energy production as much as some folks would make you believe, because things like MCT oil, it's medium chain triglyceride oil, like coconut and otherwise, don't really seem to increase performance. The Sherman and aspirin glycogen loading improve performance in the short term. Well, it just gives you a greater glycogen store. So it only matters if you're going to be doing something where you might potentially effectively exhaust your glycogen stores. If you don't do a sport that really relies heavily on anaerobic or aerobic glycolysis, it's not going to really help you. So if you're going to do something like run a marathon, do an Ironman, do a ultra marathon, it's going to help you because you're going to have a greater amount of glycogen to pull from inside of the muscle. If you're going to be doing something like lifting in a powerlifting meet, it's wasting your time. It's not really useful to really enhance your performance, maybe a little bit from a little extra water weight. But if you're doing something like the 100-meter sprint, now it's going to actively work against you because you're going to have that water retention, which in theory is going to decrease your power to weight ratio a little bit. So you're actually going to be a little slower. Quickly describe what happens in the Cori cycle. Yeah, so effectively the Cori cycle is how our body is going to take both pyruvate and lactate and cycle it back into glucose. So it allows that lactate that we produce in the muscles to then go in the bloodstream, specifically to the liver, where it'll undergo gluconeogenesis, and from there be released then as glucose, which can go back to potentially the exact same muscle fiber that produced the lactate in the first place. It's literally low density lipoprotein and high density lipoprotein. So literally the density of the two is different. And from there, HDL is effectively from our body going back to our liver, LDL is from our liver going out to our body. Too high of LDL cholesterol is essentially has a bit of a causal relationship with atherosclerosis. And we're effectively looking at cholesterol, so plaque buildups inside of our arteries. And as long as you're being really physically active, it seems to mitigate a lot of the downsides of higher cholesterol levels. But if you're sedentary, it's absolutely going to be a big deal. And the other side of it being is we just want to have a better balance of effectively what's coming to and what's going from. So it's not necessarily a bad thing, because we do need cholesterol. We have all these hormones that are cholesterol based, aka all of our steroid hormones. It's important in our cellular membranes. It's an overabundance of cholesterol that's the issue. When is the aerobic oxidative system activated, and how does it differ from beta oxidation? Well, remember, both beta oxidation and glycolysis can undergo aerobic metabolism. The key is glycolysis has the option to go both anaerobic and aerobic, whereas when we're looking with beta oxidation, that's only aerobic. So we're really using our aerobic glycolysis and beta oxidation systems pretty much 24/7. They're running all the time throughout the day. We're never shutting them down. The key is we're going to tap into that anaerobic glycolysis and that ATP PCR whenever we happen to be doing things that are of high enough intensity. So yes. Purpose of consuming creatine to help increase available creatine in the body? Yes, that is a big component. Another component is it seems to cause a little bit of intramuscular swelling, because when we increase the creatine level, we have to increase the water level in the cell, which in order to maintain osmolarity, which in turn is going to increase the fluid level, which is going to have a little bit of signaling for increasing muscle size. And so it helps not just with giving us more energy available, but it also is going to help potentially with allowing us to have effectively a little bit more fluid in the muscles, which can make them a little bigger. And slightly bigger muscles give you an advantage because you effectively are going to get hung up on them in the bottom. So it gives you a leverage advantage in movements. And how does the final differ from the midterm and is the final cumulative? It's going to be a lot of the exact same approaches to questions, and it is going to be cumulative. So yes, going to be some short answers, some matching, and a little bit of everything in between. So rock and roll. Questions?
Okay, so I just wanted to go back to the, what is it? Okay, okay, so we have the ATP PCR system, and then you go into, it's the glycolytic system, right? Or is it the oxidative?
Well, okay, remember again that we have all of the different energy systems. The key is which are we going to be emphasizing the most? We're never only using one, we're just leaning on more one than another. Okay. So if you think of your energy systems kind of like a stool, we've got 4 legs in the stool. We can balance on one of them, but if we try to balance completely on one of them, we're probably just going to fall over. So we're going on, one side of the stool more so than the other. So at rest, we're leaning mostly on the beta oxidation and a little bit of aerobic glycolysis. But if you're going like true max effort sprinting, now we're leaning really hard on the ATP PCR and anaerobic glycolysis.
Okay. And so what? Okay. So basically, I'm trying to get this right because I'm trying to get the difference. I'm trying to understand the difference between aerobic and anaerobic glycolysis. So aerobic glycolysis is just used when you're using the aerobic pathway. So like I guess like endurance exercises, and then the anaerobic is just for like high intensity.
Okay. So hopefully this is not going to confuse you, but you're going to have to stay with me for a moment here. At the end of glycolysis, we have pyruvate. Now, if we have enough oxygen available, we're going to convert that pyruvate into acetyl-CoA, and that acetyl-CoA is going to go into the citric acid cycle, just like we create acetyl-CoA in beta oxidation. Now, if we don't have enough oxygen available, we're going to convert that pyruvate into lactate. Now, it's inside of that individual fiber. So let's say you and I are going to go for a run. Some of our muscles, when they use and go through aerobic or go through glycolysis, they're going to get to that point where they hit pyruvate and there's enough oxygen in the cell that they're going to be able to send that pyruvate and convert it into acetyl-CoA, and it's going to go through the citric acid cycle. Whereas some of your fast twitch type 2 fibers are going to already become anaerobic. So they're going to have to convert that into lactate as opposed to into that acetyl-CoA. And so whenever we're doing exercises, some of your muscles are going to be aerobic the entire time, no matter how high your intensity goes. They just have that great of ability. That's your type 1 fibers and ones that have really good capillarization, et cetera. Whereas some of your fibers, those type 2s, as soon as you tap into them, you're going to be producing lactate because they are garbage at aerobic metabolism.
Got it. And then with endurance exercise, I remember you talking about how with endurance training, you get better at the clearance of lactate?
Yes. Yeah, so your production of lactate is likely to be very similar. The key is we're going to do a better job of utilizing lactate in those, remember like the fast twitch fiber produces it, but then I'll have the slow twitch fiber next to it. The slow twitch fiber is going to do a better job of picking it up and using it, or it's going to go into our bloodstream and then our heart's going to use it as a fuel, our other slow twitch muscle fibers are going to use it as fuel, and our brain can even use it as a fuel. In fact, lactate's a preferred fuel of your brain.
Okay, and then when do ketones come in and play a factor?
So ketones are a bigger issue with starvation, and specifically whenever we don't have enough carbohydrate. Since your brain really likes to use carbs as a fuel, and lactate is a carb, whenever we happen to be in a source of starvation or obviously in a high-fat diet with pretty much little to no carbohydrate and moderate to little to no protein, we're going to have to use another fuel aerobically for our brain to function because the brain does not do well running on fats as a fuel. And so ketone bodies are going to be produced by your liver. And these effectively are created through kind of only midway metabolism of fatty acids. That's where you get like acetone, BHT, beta hydrobutyrate, butyric acid, something along those lines. But those are going to go ahead and naturally be produced, and that's going to go into your bloodstream, and that's what your brain is going to use aerobically for fuel.
Got it. Okay.
Her name is Dr. Sheila.
So we can review for as long as you want. If this is all the questions you got for now, that's absolutely fine. You can obviously go ahead and shoot me an email of some more questions, and I'm more than happy to and keep breaking down different aspects to,
Okay.
you know.
Perfect. Thank you. I was just like reviewing some of the notes from over the weekend, and these were just the ones that like popped it, like the other ones I just was really unsure. So okay, real quick, reacidification is just basically your body. The purpose of your body doing is just to store fat.
Yeah, it's just to effectively convert fat back into its storage form.
Okay, got it. That makes sense. Okay, cool.
Yeah. All right. And so actually, I realize I've got two more questions and they're relatively quick, which is how does the body adapt metabolically to different types of training? Whatever energy system you're focusing on more, you're going to effectively have cellular signaling about either low glycogen levels, PGC1 alpha for increasing our mitochondrial levels, and we're going to literally increase the number of enzymes related to those energy systems. And when we're talking about aerobic systems, we're also going to increase the number of mitochondria inside of those cells. And so we have to give the body a big enough stimulus that effectively we're going to get that cell signaling to occur that we need to improve the specific components so that we're going to be able to, you know, have that better performance. And when it comes to thyroid hormone functioning and metabolism, that really kind of helps set the basal metabolic rate of the body. Too much and you're going to be jittery and you're not going to feel like you never stop and slow down, but too little, you're going to be very lethargic and very tired. So it actually does help with the natural energy turnover rate and effectively cellular metabolism in all the tissues of your body. So, Alex, if you don't got any other questions, bud, I know we got through all the major ones that were asked. Don't worry, I will never judge you on spelling. We are here instead to learn. And yeah, otherwise, have yourself a great night, and we will go through and we will review again effectively for the next 2 weeks, well, next week. And then you guys will have your presentations for those journal article review, which is once again, pick a topic. We talked about this earlier in the semester that you like. You're going to look at least 10 articles in that area. You're going to synthesize that information and give us the broad overview. And then you'll submit that online. We'll put up a discussion board so you guys can all look at each other's. And then one question on the final exam will be over everybody's review paper. So.
Perfect. And that's the journal article is just a lit review, correct?
Yeah, it's a lit review. And then so you're going to not just write the paper, but you're going to present it to your classmates.
All right. Sounds good.
All right, bud. Well, stay safe out there, and I will chat with you more soon.
Thank you. Bye-bye.
All right. Bye-bye.